Okay, good morning students. Now we'll continue with the differential equations part of linear differential equation, which is the last part. Already we have discussed the differential equation, right? Differential equation we have discussed two cases. One is variable separable, second one is homogeneous. The third one is the linear differential equation, which we'll be applying for solving the different integration or general integration of the given differential equations. Okay, so such cases what happens? When it comes to the form, we have to identify the form of the differential equation, right? So in that case, what happens? If the differential equation is of the form dy by dx plus py is equal to q, then it's a linear differential equation. Again, it has two forms, like homogeneous, it has two forms, dx by dy and dy by dx. But again, dx by dy syllabus was deducted from this year due to this reduction of syllabus by the corona pandemic. But we'll discuss both the cases because of keeping in view your external examinations or competitive examination pattern. But we stress upon dy by dx cadre. Okay, part. Dx by dy also we'll discuss, but we stress upon dy by dx because dx by dy is not in syllabus, but dy by dx is there. But anyway, we discuss dx by dy also. If at all you have this application in your competitive examinations in AIEEE or IIT or other MSCET like examinations. Same way we have discussed in the homogeneous also. In homogeneous also there is no dx by dy, but we have discussed. Okay. Similarly, we have discussed other cases, even curve to curve, line to curve in different integrals also. We are covering the out of syllabus for this year, but it is syllabus for the previous years and the next years also. So we are covering the whole syllabus, but stressing upon the actual syllabus, which is for this year, because some part was deducted, already. Anyway, chapter wise we will discuss again, review upon it. Okay, so we go with the last part of the solving of the differential equation. Right now, solving of linear differential equation. This is the case we have to discuss. Okay, so linear differential equation. What is linear differential equation? First, we should know. Then only we can solve it. Now, without knowing what is linear differential equation and without identifying what case it comes to be, so how do we discuss solving type? So first we discuss the what is linear differential equation. Then we'll discuss about how to identify it. Then we'll discuss about the solving of the linear differential equation. Okay, now we'll see here. dy by dx first order first degree differential equation. What is a linear differential equation? We are defining it first. Okay, we are defining a linear differential equation. A first order and first degree differential equation in which Now see here, there are two types of differential equations. A first order, first degree differential equation. So dy by dx should have only power 1 and dy by dx only will come. And the degree of dependent variable, one dependent variable y. Independent variable is x. Degree of dependent variable and its derivative is, so dy by dx and y both are 1 and they do not get multiplied. So y into dy by dx will not come. Okay? This is called the differential equation, which is called linear differential equation. Now we discuss this part in detail. Okay, type wise. Okay, so what we discuss here is there are two types of linear differential equations. Let us see it. First, type 1. An equation of the form dy by dx plus py is equal to q, where p and q are constants or functions of x only. Example, dy by dx plus 2y is equal to sin x. P is equal to 2, Q is equal to sin x. So both can be constants or one can be function of x or both can be functions of x. Right? Second case, type 2. An equation of the form dx by dy plus px is equal to q, where p and q are constants or functions of y only. Dx by dy plus minus x by y is equal to y square. Here p is equal to 1 by y, q is equal to y square. Now see, this is functions of y in dx by dy. Here function of x in case of dy by dx. So both cases can be there. See here y into dy by dx did not come. Here also y into dx by dy did not come. Functions of y, functions of x, p and q are constants. Dy plus py, dx by dy plus. So what comes here? Same one will come. Plus px is equal to q. Again p and q are constants or functions of y. So these are the two cases of the differential equations which are called as the linear differential equations. So linear differential equations, there are two cases. One is dy by x plus py is equal to q, and the second one is dx by dy plus px is equal to q. I think you understood. Now we discuss this type of first type of linear differential equation solving and second type of linear equation solving. But syllabus is only for type 1. Like homogeneous, you have dy by dx form. Dx by dy also. But again, I told you syllabus is for dy by dx only, homogeneous also. They have reduced the syllabus. So second case we discuss, but will not stress upon practice in terms of board revision. Are you clear? So dx by dy case we will discuss, but we will discuss less, and dy by dx cases we will discuss more. So what is linear differential equation understood now? First order, first degree, in which dependent variable and its derivative has only 1 degree and they cannot get multiplied. So any case we have to see, because these definitions are useful for us in identifying the type of the differential equation. You are all given the differential equation solving only at a time. So you should know it is either which is variable separable or homogeneous or linear. Okay, so directly if you don't know the definition, you cannot say it as which type of differential equation. If it is identified as a specific type, then only you can solve it. Otherwise, you cannot solve it. If you don't know what is the type of the differential equation, you cannot solve it now. So identifying the differential equation is very important, whether it is linear or homogeneous and variable separable. So there are certain landmarks for you. Suppose in case of variable separable, x and y are able to be separated. X and y are with into and divided by. And in the case of homogeneous, degree of x is degree of y, and dy by dx should be same order, and numerator should be greater than or equal to denominator, and put lambda x is equal to lambda x, y equal to lambda y, then checking, then y is equal to vx in case of dy by dx, x is equal to vy in case of dx by dy. So likewise, again in the case of the linear, so dy by x plus py is equal to q, p and q are functions of x, and dx by dy is equal to plus px is equal to q, where p and q are functions of y. But this case again not there syllabus. Similarly, in case of differential homogeneous, dx by dy case also not there. So I think you are clear with this part. Now we discuss the solving type of the linear differential equation. So I am erasing this part. Okay, how to solve? We have identified now. We have defined. Then we are solving the type of linear differential equations. See here. Now, step 1, solving method. Linear differential equation. Step 1. Identify the type of linear differential equation by locating P and Q. First step, what type of step? This is linear dx by dy form or dy by form, and identify P and Q. Okay. Find the integrating factor. E power integral P dx or e power integral P dy as per the form of linear differential equation. So in case of dy by dx, e power integral P dx, if x is the functions of P and Q are functions of x, here P and Q are functions of y, e power integral P dy. Okay, like that. Second case, that is called integrating factor. Integrating factor is these two. Third case, step 3. Find the solution of given differential equation by using the formula y into if is equal to integral q into if dx plus c, or x into if is equal to integral q into if dy plus c. Next case, fourth one is note. In case of particular integral, okay, substitute x and y for general solution and find C to get the particular at a given point or passing through. So in case of particular solution, already you know, in the general solution you substitute P x and y, then you get C, and then you get the value. So there are two cases again here. This comes under first case and this comes under second case. So IF is same only. IF also according to differential type. This is first case, this is second case. Okay. So this is what. So P and Q are key, and then type of linear differential equation is key. Then IF is important. Then IF found. Then use the formula and then substitute. And if you are required for the specific or particular solution, put x and y values and then C value and then substitute the C value. Right. These are the steps, and we'll accordingly will proceed with this pattern. Okay, clear? Now we'll see an example. Not all. Okay. Next. Next example, we'll see backward problem. Find a general solution of the following differential equation. E power 2x into over dx plus 3 e power 2x into y is equal to 1. Okay. So given differential equation is of the form dy by dx plus py is equal to q if e power 2x in, because dy by dx should not have any quotient. Dy by dx is divided both sides. Divided with e power 2x both sides, as coefficient of dy by x should be 1. This is very important. So remember this part, you have to have the dy by dx quotient as 1. So divide by dy by e power 2x both sides. So what happens? It implies dy by dx plus 3 into y is equal to e power minus 2x, where p is equal to 3, q is equal to e power minus 2x. If is equal to e power integral p dx. So e power integral 3 dx, which is equal to e power 3x. Therefore, solution of the given differential equation is dy over x plus py y into if is equal to integral q into if dx plus c y into e power 3x. The q means e power minus 2x into e power 3x dx. That's it. Which is equal to e power x. So y into e power 3x is equal to e power x plus c. Is the required solution. No, no. Yes, understood. We'll discuss one more question now. So if you ask this particular solution, you will give x and y values or passing through the point or else at the point, then you will find c and then you sub. That is same for all cases, either variable separable or homogeneous or linear. Okay. So if it is not direct in differential form, then you have to convert it by suitable application. Okay, standard form you require. Okay, next. Dy square minus x into dy is equal to y dx. Now it looks to be dy over dx form, but and here 1. So it is not linear. It is not homogeneous. See, here x square is there, here y square is there, then it comes to homogeneous. So when you are doing the upside, you get down to dy over dx form, you take y by 3y square minus x. Y degree is 1, y square degree x is 1. So it is not homogeneous. So you have to go for it as to be converted, dy over dx plus py. Okay, first dy over dx to divide. Sometimes it comes to dx by dy also. So first you have to go for suitable substitution. 3y square minus x into dy is equal to y dx. So y is small now, so there you take dx by dy. Dx by dy is equal to 3y square minus x by y, which is equal to 3y minus x by y. So dy by dx plus x by y is equal to 3y is of the form dx by dy plus px is equal to q. P comma q are functions of y. Where p is equal to 1 by y and q is equal to 3y. Okay? Therefore, p is equal to 1 by y, q is equal to 3y. So if is equal to e power integral p dy, which is equal to e power integral 1 by y dy, which is equal to e power log y to the base e, which is equal to y. Since e power log x to the base e is equal to e by standard identity, by standard function. So you have to use it. Okay? So this is y equal to x. Therefore, solution is x into if is equal to q into if dy, which comes to be plus c. X into if is equal to y is equal to q means 3y into y dy plus c, which is equal to y cube. X into y is equal to y cube plus c. Which is the required number solution. Is the required okay? So that you have to see how it comes. This is very critical observation you require for this part. Once you got it, then you can get the solution and the other parts. Okay? So e power log x is equal to x. That is very important for you. The standard function you have to remember it. Next, we go one more question. X square minus 1 into dy by dx plus 2xy 1 by x square minus 1. X square minus 1 into dy by dx plus 2xy is equal to 1 by x square minus 1. Dividing with x square minus 1 both sides to see the quotient of dy by dx is 1. Okay, now because dy by dx should be linear, so that should be having no quotient for dy by dx. Okay, so dividing with x square minus 1, we have to divide both sides, and what happens? Dy by dx plus 2xy by x square minus 1 is equal to 1 by x square minus 1 whole square. These are the form dy by dx plus py is equal to q. P and q are functions of x. Therefore, p is equal to 2x by x square minus 1, q is equal to 1 by x square minus 1 whole square, if is equal to e power integral p dx, which is equal to e power integral 2x by x square minus 1 dx, which is equal to e power log x square dx, which is equal to x square minus 1. Then solution is y into if is equal to into if dx plus c plus y is y only, y into x square minus 1 is equal to q means 1 by x square minus 1 whole square into x square minus 1 dx plus c. So y into x square minus 1 is equal to 1 by x square minus 1 dx plus c. This is 1 by x square minus a square, which is y into x square minus 1. 1 by x square minus 1 is equal to 1 by 2 over x minus a into x plus a. X minus 1 by x plus 1 plus c. That is the answer. This is the required general solution. Not done. Okay. Next question. In the next question. What will be the IF of given differential equation? Y ds plus x minus y square dy is equal to 0. So the solution given differential equation is y dx plus x minus y square dy is equal to 0. Y dx is equal to minus y square minus x into dy. So dx by dy is equal to y square minus x by y, which is equal to y minus x by y. So dx by dy plus x by y is equal to y is of the form dx by dy plus dy is equal to q. P and q are functions of y. Therefore, if is equal to equal p dy. So p is equal to 1 by y. Dx. Q is equal to y. So e power integral 1 by y dy, which is equal to e power log y to the base e, which is equal to y. General solution is y x into if is equal to integral q into if dy plus x into if means y is equal to q into y, which is equal to implies xy is equal to y by 3 plus c. The required general solution. So always you should see dx by dy or dy by dx will come with higher degree by lower degree. That's why it is to be divisible. Like that you have to take. Okay, next we'll do one more question. We asked IF only, but we have found the solution also. Okay. Next. These are for 1 mark question will come. X divided by x minus y is equal to x square. See, always you have to remember quotient of x should be there. Okay. So in order to make quotient of x divided by x 1, what should be? You have divided by x square. X divided by dx minus y is equal to dividing by x both sides. So dy by dx minus y by x is equal to 2x. Is of the form dy by x plus py is equal to q, where p is equal to functions of x, p is equal to minus 1 by x, q is equal to 2x. So IF is e power integral p dx, e power integral minus 1 by x dx is equal to e power minus log mod x, that is equal to e power log 1 by x, which is equal to 1 by x. Yes, solution is y into IF integral q into IF dx plus c 1 by x is equal to integral q into 2x into 1 by x dx plus c. That implies y by x is equal to 2x plus c is the required general solution of the required differential equation. So he asked for only IF means what happens up to here you will get, then it will be 1 mark question. But we practice up to general solution, because if you are getting 1 mark or 2 marks in number, you will practice the whole question. Okay? Okay? Solve. Solve the differential equation x 4 divided by x plus 5 8y is equal to 5 equal to 3 minus x. Four divided by dx plus 8y is equal to 5 into e power a by dx plus 8y by 4 is equal to 5 by 4 into e power minus 3x is of the form dy by dx plus py is equal to q. P and q are functions of x. So p is equal to 2, q is equal to 5 by 4 into e power minus 3x. Therefore, I f is equal to e power integral dx, which is equal to e power integral 2 dx, which is equal to e power dx. General solution is y into if is equal to integral q into if dx plus c. Therefore, y into e power 2x is equal to q means 5 by 4 into e power minus 3x into e power 2x dx plus c. 5 by 4 into e power minus x dx, which is equal to 5 by 4 into e power minus x by minus 1. Therefore, y into e power 2x is equal to minus 5 by 4 into e power minus x plus c with the required general solution. Because dy by dx question should be 1. There should not be any other question to multiply with dy by dx. Right? We will continue. X dy by dx plus y minus x plus xy cot x is equal to 0. X not equal to 0. Because x not equal to 0, y is given. Because to make this differential equation, right, as differential equation of the linear form, you should not have any question multiplied with dy by dx. So x you have to divide. That's why x not equal to 0 given. So this hint is given directly that you have to divide with x, and it is a linear equation form. Okay, x divided by dx plus y minus x plus xy cot x is equal to 0 divided by x both sides. So dy by dx plus y by x minus 1 plus y cot x is equal to 0. You just transform dy by x plus py is equal to q. So y by x is equal to 1 minus y cot x. Okay, these are the form dy by x plus py is equal to q. P and q are functions of x. P is equal to 1 by x. Q is equal to okay. Directly conjugate. So plus cot x, y cot x is equal to 1. Again, dividing with the cortex. Because it should not have x and y together, na? Dividing with cortex both sides. First, you have to go like this. So it is again coming cortex mixed, na? So what we go here? dy by dx, x dy by dx plus what will be common? Y into okay, this x will come here. Y into 1 plus x cortex. Okay, x will come here. Therefore, dy by dx plus y by x into 1 plus x cortex is equal to 1. Is of the form a by x plus py is equal to q. P and q are functions of x. P is equal to 1 plus x cortex by x. Q is equal to 1. Therefore, IF is equal to e power integral p dx, which is equal to e power 1 plus x cortex by x dx, equal to e power 1 by x dx plus integral cortex dx, which is equal to e power log x to the base e plus log naught sin x, which is equal to e power log x sin x to the base e, that is equal to x sin x. Therefore, general solution is y into if is equal to integral q into if dx plus c. That implies y into x sin x. Integral q means q is 1 into x sin x dx plus c. Again, you have to find this as uv. This is u, this is v. So xy sin x is equal to u into integral v dx. So x into minus cos x minus integral of plus integral cos x dx plus c. That is equal to minus x cos x plus sin x plus c. That is xy sin x is equal to. That is the general solution. Note down. We are clear?